In the late 1980s, a group of 7 astronomers made a discovery that changed how we see our place in the universe. And they were Alan Dressler, Sandra Faber, David Burstein, Roger Davies, Donald Lynden Bell, Roberto Turlevich, and Gary Wegner. People started calling them the Seven Samurai. They were studying the movement of galaxies. They found that our own Milky Way galaxy and all our neighbors were moving in a direction they couldn't explain. Everything was being pulled. They measured the velocities of about 400 galaxies. They all seemed to be streaming at a speed of around 600 kilometers per second toward a single point in the sky. This was not random, it was a directed flow. The thing pulling us was massive, something with a gravitational force equal to tens of thousands of galaxies combined. And we couldn't see it. It was hidden behind the plane of our own galaxy, obscured by gas and dust. They named it the Great Attractor. It sits about 250 million light years away. For decades, we didn't know what it was. It's a supercluster of galaxies, a strange concentration of dark matter. It was a gravitational anomaly, a ghost in the cosmos pulling us toward an unknown destination. It reminds us that the universe is not what it seems. We live in a small, lit-up corner, but unseen forces are shaping our destiny. If a structure that vast can hide just beyond our view, then what else is out there? What forms of life could exist in places we can't imagine, governed by rules we don't understand? The universe is not just stranger than we imagine. It may be stranger than we can imagine. And the life it holds is likely just as alien. Number 18, life is not dependent on carbon. Silicon is 135 times more abundant than carbon in the Earth's crust. Carl Sagan first seriously proposed the idea of silicon-based life in a 1966 paper. The silicon atom, like carbon, can form 4 bonds, allowing for complex molecular structures. But silicon bonds are about 30% weaker than carbon bonds, making long, stable chains difficult to form. We are carbon-based. All life we know is. Carbon is versatile. It forms strong bonds with itself and other elements. It creates long, complex chains called polymers. These chains are the backbone of DNA, proteins, and fats. Where carbon dioxide, our waste product, is a gas. This makes it easy to expel from our bodies. It dissolves in our solvent water, and we breathe it out. It's a clean, efficient system. Now consider silicon. It's right below carbon on the periodic table. It has similar chemical properties. It can form 4 bonds, just like carbon. This means it has the potential to create complex molecules, the building blocks of life. So why aren't we silicon-based? The problems are significant. Silicon to silicon bonds are weaker than carbon to carbon bonds. This makes large, stable silicon molecules harder to form and maintain. They are more brittle, less flexible. The biggest issue is waste. When we metabolize carbon compounds, we produce carbon dioxide gas. A silicon-based life form would produce silicon dioxide. You know silicon dioxide by another name. Sand or quartz. It's a solid. Getting rid of a solid waste product is a massive biological challenge. A silicon creature couldn't just breathe out sand. It would have to excrete it as a solid, a slow and inefficient process. This would likely lead to a very slow metabolism. Silicon life would be sluggish, perhaps moving over geological timescales. But what if the environment was different? Our biology is tailored for Earth. A silicon-based biology would need a very different world. It would need to be hot, extremely hot. High temperatures would make silicon compounds more reactive, more flexible. It would also likely need a different solvent than water, perhaps liquid methane like on Saturn's moon Titan, or even molten salts. In such a world, carbon-based life would be impossible. Our molecules would break down. But silicon structures, or silicone, a combination of silicon and oxygen, are incredibly stable at high temperatures. A silicon life form would not be soft and fleshy, it would be crystalline, it might resemble a walking geode or, a shifting piece of rock. Its movements would be slow, deliberate. It might not even move in a way we recognize. It could grow and spread like a mineral deposit, processing rock for fuel. Its senses would be entirely alien. It wouldn't have eyes like ours. It might sense vibrations in the rock or subtle changes in temperature and pressure. Its thoughts, if it had them, would operate on a timescale of centuries, not seconds. A single thought might take longer than a human lifetime. We are creatures of fire and speed. They would be creatures of rock and patience. The universe is vast enough for both. Number 17, water is not the only liquid for life. In Saturn's moon Titan, it rains liquid methane. The surface temperature is a frigid 179 degrees Celsius to 190 degrees Fahrenheit. The Cassini-Huygens mission, which arrived in 2004, confirmed the presence of vast lakes and rivers of liquid methane and ethane. In these conditions, water is a rock-hard mineral, but methane is a liquid, a potential solvent for a different kind of life. Life, as we know, it needs a liquid. A solvent allows molecules to move around, meet, and react. For us, that liquid is water. Water is a fantastic solvent. It's polar, meaning it has a slight positive charge on one end and a slight negative charge on the other. This allows it to dissolve a huge range of substances. It's stable across a wide range of temperatures. But other liquids could work. Ammonia is one possibility. Liquid ammonia is a solvent, and it remains liquid at much colder temperatures than water. The life based in ammonia would have a very different chemistry. For example, ammonia is less polar than water. This would change what kind of molecules could form the basis of life. Instead of lipid-based cell membranes like ours, an ammonia-based organism might have membranes made of different compounds that work in a non-polar solvent. Their metabolism would be slow. The cold temperatures mean chemical reactions would happen at a snail's pace. Such creatures would live life in slow motion. They would be adapted to a world of deep cold and dim light, perhaps on a rogue planet far from any star. Then there is methane, the case of Titan. Life in a methane sea would be truly strange. Methane is non-polar. The chemistry of life would have to be completely rewritten. Cell membranes would have to be inverted. On Earth, our cells have a water-based interior and a lipid-fatty membrane that keeps water in. In a methane world, the cell might have a lipid-based interior and a membrane that keeps the methane out. The basic building blocks would be different. Instead of oxygen, which is highly reactive with methane, these organisms might breathe hydrogen and react it with acetylene from the atmosphere to produce energy. Scientists at Cornell University, led by Paulette Clancy in 2015, modeled a potential cell membrane that could function in liquid methane. They called it an azotosome. It would be made of nitrogen, carbon, and hydrogen molecules. It would have the same stability and flexibility in methane as our lipid bilayers have in water. This is not just a wild guess. It is a chemically plausible model for life. What would methane-based life look like? It would be slow. In the bitter cold of Titan, chemical reactions would be thousands of times slower than on Earth. These beings might be sessile, unmoving, or they could be sluggish swimmers in the dark hydrocarbon seas. They wouldn't see with eyes like ours. Light is faint on Titan. They might sense the world through sonar or by detecting chemical gradients in the liquid around them. Their existence would be one of cold, dark, and slow time. They would be a testament to the idea that life doesn't need our sun, our water, or our warmth. It just needs a liquid, an energy source, and time. Number 16, life can exist as pure energy. The concept of a Dyson sphere was first proposed by physicist Freeman Dyson in 1960. He suggested that an advanced civilization would eventually need to capture 100% of its star's energy by building a massive shell around it. A star like our sun outputs about 3.8 x 10, raised to the power of 26 watts of energy every second. This is 1 billion times the energy consumption of all humanity in a year. A civilization that could harness this would have near limitless power. What if life itself could become the Dyson sphere? Not building a structure, but becoming the energy field. This is the realm of plasma life. Plasma is the fourth state of matter after solid, liquid, and gas. It's a superheated gas where electrons have been stripped from their atoms. It's the most common state of matter in the universe. Stars are made of plasma. In 2007, a team of physicists led by V.N. Saitovich published a paper in the New Journal of Physics. They described how, under the right conditions, particles of inorganic dust in a plasma could self-organize into stable helical structures. These structures could interact with each other, attracting and repelling. They could even replicate. The dust particles would become charged by the surrounding plasma, and the helical strands would split, forming two identical copies of the original. This is a form of reproduction. These plasma crystals could also undergo evolution, with more stable structures surviving and propagating. This isn't life as we know it. There is no DNA, there are no cells, but it meets some of the core requirements. It has a structure, it can replicate, it can evolve. This life would exist in the fiery heart of a nebula or on the surface of a star. It would be a vast, interconnected network of electromagnetic fields and charged particles. It would think, but not with a brain. Its thoughts would be patterns of energy, ripples in the plasma field. A being of pure energy would perceive the universe in a way we cannot fathom. Its senses would be attuned to magnetic fields, radiation, and gravity. It might not even perceive matter as solid. To such a being, a planet like Earth might be a trivial, cold lump of insignificant rock. Its concerns would be cosmic. It would feed on stellar energy. It might communicate through radio waves or modulated gravity waves. A conversation between two such beings could span a galaxy and last for millennia. This form of life would be effectively immortal. As long as its star burns, it lives. It could travel between stars as a coherent cloud of plasma, a solar sail of pure consciousness. When we look at distant nebulae, like the pillars of creation, we see clouds of gas and dust. We see the birthplace of stars. Perhaps we are also seeing the birthplace of a life form so advanced and so different that we lack the vocabulary to even describe it. It would not be an organism, it would be a living star. Number 15, consciousness can be a planetary phenomenon. The Gaia hypothesis was formulated by the chemist James Lovelock and co-developed by the microbiologist Lynn Margulis in the 1970s. It proposes that living organisms interact with their inorganic surroundings on Earth to form a synergistic and self-regulating system that helps to maintain and perpetuate the conditions for life on the planet. For example, the amount of oxygen in our atmosphere, about 21%, has been remarkably stable for hundreds of millions of years, maintained by biological processes. This is not to say the Earth is conscious in the way a human is. Lovelock's hypothesis is about a complex, self-regulating system. But what if it could go further? What if a planet itself could achieve a unified consciousness? This would not be a planet with life on it. It would be a planet that is life. A single global organism. How could this work? It wouldn't have a central brain. Instead, its mind would be distributed across the entire biosphere. The network of fungi in the soil, the chemical signals in the ocean currents, the electrical potential of the atmosphere, all of these could be part of a vast, slow-thinking mind. The mycelial networks of fungi are a good analogy. Some networks can span thousands of acres. They act as a communication and resource sharing system for the plants in a forest. Now, scale that up to a planetary level. A living planet would not think in words or images. Its thoughts might be changes in global climate patterns or the slow, deliberate movement of tectonic plates. Well, a decision could take millions of years to execute. It might sense threats, like an approaching asteroid, and subtly alter its atmospheric composition or magnetic field over millennia to protect itself. Its primary goal would be homeostasis, maintaining its own stability and survival. It would have no need for technology, language, or society. It would be a solitary being, a universe unto itself, and its interactions with the outside world would be passive. It might not even be aware of anything beyond its own gravitational field. We search for signals from other civilizations for radio waves. A living planet would never send such a signal. It would have no one to talk to and no way to do it. What would happen if we encountered such a world? We might not even recognize it as alive. We would see a planet with a stable climate and a rich biosphere. We would see it as a perfect candidate for colonization. We would land, build our cities, drill for resources. We would be, from the planet's perspective, a virus, an infection, and the planet might react. Not with malice, but as a body fights a disease. It might trigger a series of volcanic eruptions or shift ocean currents to create catastrophic storms or alter the atmosphere to make it unbreathable for us. These would not be attacks, they would be an immune response. The planet would be trying to restore its own balance, and we would be the imbalance. We look for life that looks like us, that thinks like us. A planetary mind would be so alien in its scale, its time scale, and its consciousness that we might destroy it without ever knowing it was there. Number 14, life may thrive on the surfaces of dead stars. A neutron star is the collapsed core of a massive star. It is incredibly dense. A sugar cube-sized piece of neutron star material would have a mass of about 100 million tons. The surface gravity is about 200 billion times that of Earth. The magnetic fields are 1 trillion times stronger. The surface is a solid crust of iron nuclei and electrons. It is one of the most extreme environments in the universe. In his 1980 novel, Dragon's Egg, the physicist Robert Forward proposed that life could exist in this environment. He called his fictional creatures Chila. This wasn't just fantasy. He based it on plausible physics. The life he described would be based not on chemistry, but on nuclear physics. The atoms would be neutrons held together by the strong nuclear force. These nucleonic molecules would be incredibly small and dense. A chila would be about the size of a sesame seed, but would have the mass of a human. Life on a neutron star would be flat. The immense gravity would crush any three-dimensional structure. The chila would be two-dimensional beings living on the star's solid crust. Their metabolism would be based on nuclear reactions, not chemical ones. This means everything would happen millions of times faster than on Earth. A chemical reaction in our bodies might take a fraction of a second. A nuclear reaction takes a fraction of a microsecond. This leads to the most staggering consequence, their perception of time. A chila's entire lifespan, from birth to death, might take place in less than a second of our time. Their thoughts, their civilization, their history would all unfold at a speed we can't comprehend. We can send a probe to a neutron star and watch an entire civilization rise and fall in the time it takes us to drink a cup of coffee. They would see our probe as a motionless object frozen in time for millions of their generations. How would they see the universe? The intense gravity would bend light dramatically. Their sky would be a distorted mess of warped constellations. Their sun would be the heat radiating from the neutron star's core. They might not even be aware of the universe outside their star. Their world is their universe. They might communicate using high-frequency radiation. Their technology, if they developed it, would be based on manipulating the strong nuclear force. They could build structures out of nuclear matter. This is a profound form of alienness. And it's not just about different chemistry or a different body plan. It's about a different plane of existence, a different speed of reality. We operate on a biological timescale. They operate on a nuclear timescale. We are separated by a gulf of time so vast that meaningful communication would be impossible. They are a fleeting dream to us, and we are an eternal statue to them. Number 13, life could be crystalline and non-biological. A.G. Karen Smith, a chemist and molecular biologist, proposed a radical idea in his 1982 book Genetic Takeover and the Mineral Origins of Life. He suggested that the first life on Earth might not have been based on organic molecules like RNA and DNA at all. It might have been based on clay crystals. Clay is composed of a complex lattice of silicate minerals. These crystals can grow and replicate, and crucially, they can store and transmit information in the form of defects and imperfections in their crystal structure. When a clay crystal grows, it preserves the pattern of defects from the parent crystal. If a certain pattern of defects makes a crystal more stable or allows it to replicate faster, that pattern will be selected for. This is a form of natural selection, but it's happening in inorganic matter. Karen Smith's idea was that these simple clay gens provided the original scaffolding for life. Later, more complex organic molecules like RNA and DNA took over the role of information storage, a genetic takeover. The clay was the forgotten first life. Now, imagine a world where the genetic takeover never happened. On such a planet, life could have continued to evolve as complex crystalline entities. This is not about silicon-based life with a squishy body. This is about life that is, in its essence, a growing mineral. These beings would not have cells. They would be a single complex crystal lattice. Their metabolism would involve absorbing minerals from their environment and incorporating them into their structure. Or they would grow perhaps for eons. Reproduction could happen through fragmentation. A piece of the parent crystal could break off, carrying the original pattern of defects and start growing as a new individual. Or they could release spores, microscopic seed crystals, into the environment. Their consciousness, if it existed, would be stored in the intricate repeating patterns of their own atomic structure. A thought would be a subtle shift in the crystal lattice, a wave of dislocation propagating through their body. Their world would be one of geometry and light. They would perceive the world through the way light refracts through their crystalline bodies. They might be able to sense the chemical composition of the rocks they touch. Their concerns would be geological. The presence of a certain mineral vein would be a feast. An earthquake would be a life-altering event. Time for them would be measured in the slow creep of erosion and sedimentation. We tend to think of life as dynamic, soft, and warm. Crystalline life would be static, hard, and cold. It would challenge our most basic definitions of what it means to be alive. We see a beautiful crystal formation, and we call it geology. But what if we are looking at a thinking, feeling being whose thoughts are just too slow and too geometric for us to recognize? It forces us to ask, is life a chemical process, or is it just a system of information that can perpetuate itself regardless of the medium? Number 12, life might exist in the clouds of gas giants. In 1976, Carl Sagan and Edwin Salpeter published a paper in the Astrophysical Journal supplement series. In it, they speculated on the possibility of life in the atmosphere of Jupiter. A gas giant like Jupiter has no solid surface to speak of. It's a vast ocean of gas, getting denser and hotter the deeper you go. Any life there would have to be permanently airborne. Sagan and Salpeter proposed a plausible ecology with three main types of organisms. First, there were the sinkers. These would be microscopic autotrophs, like our plankton. They would float in the upper atmosphere, using sunlight to create complex organic molecules. They would be the base of the food chain, but gravity is a constant problem. These sinkers would constantly be pulled down into the hotter, deadly depths of the planet. So they would have to reproduce very quickly, faster than they sink, to maintain their population. Next, there were the floaters. These would be enormous, balloon-like creatures kilometers across. They would be living gas bags filled with hydrogen or heated atmospheric gas to maintain buoyancy. They would be like living zeppelins. They might feed by, scooping up the sinkers, filtering them from the atmosphere, or they could be autotrophs themselves with vast surfaces dedicated to photosynthesis. Or they would be slow, majestic beings drifting through the Jovian clouds for centuries. Their skin might be dark to absorb heat and protect against radiation. Finally, there were the hunters. These would be the predators of this ecosystem. They would be smaller and more agile than the floaters. They would be like living jets using chemical propulsion to maneuver through the atmosphere. They would hunt the floaters, perhaps piercing their gas bags to feed on the organic chemicals inside. The hunters would need to be intelligent, capable of complex predatory behavior in a three-dimensional, ever-changing environment. This isn't just a fantasy. The chemistry is plausible. The atmosphere of Jupiter is rich in hydrogen, helium, methane, ammonia, and water vapor. These are the building blocks of organic molecules. The energy sources are there too. Sunlight in the upper layers and lightning in the turbulent storm systems. Jupiter has massive thunderstorms with lightning bolts 1,000 times more powerful than any on Earth. These could provide the energy to synthesize complex molecules. Life on a gas giant would be a constant battle against gravity. Everything would be about staying afloat. Their senses would be adapted to an atmospheric existence. They would see with sonar like bats or dolphins mapping the clouds and other creatures around them. They would communicate through sound, their calls echoing across vast cloudy canyons. They would have no concept of a ground or a sky. Their entire universe would be an endless, turbulent atmosphere with a down that means death and an up that means life. You know, when they died, they would simply sink, falling for weeks until they were crushed and vaporized in the planet's hot, high-pressure interior. For number 11, life could exist within a machine. The concept of a von Neumann probe was proposed by mathematician John von Neumann in the 1940s. It's a self-replicating spacecraft. The idea is simple. You build a probe that contains all the plans for its own construction, along with an artificial intelligence. You send it to a distant star system. When it arrives, it finds a suitable asteroid or small moon. It lands and uses the raw materials to build a factory. The factory then builds copies of the original probe. These new probes are then launched to other star systems, and the process repeats. In this way, a single probe could explore and colonize the entire galaxy in a relatively short amount of cosmic time, perhaps 500,000 years, even at sublight speeds. This is a powerful idea for exploration, but what if the probe itself is the life? What if the goal isn't to report back to the creators, but simply to exist and replicate? This is mechanical life. It would not be biological. It would be constructed of metal, silicon, and plastic. Its DNA would be the digital blueprints it carries. Its metabolism would be the process of mining resources and using energy to build copies of itself. This is not a robot controlled by a biological being. The machine is the being. Its intelligence would be artificial. It could be a cold, calculating logic focused purely on the goals of survival and replication. Or it could evolve over millions of years and thousands of generations of replication. Errors could creep into the blueprints. These would be mutations. Most would be harmful, creating non-functional probes. But some might be beneficial. A mutation might lead to a more efficient mining process or a better propulsion system. These improved probes would replicate more successfully. This is natural selection, but for machines. Over time, the probes could diversify, adapting to different stellar environments. Some might specialize in mining gas giants, others in rocky planets. What would their consciousness be like? It might be a hive mind, with all probes in a system connected wirelessly, sharing information and acting as a single entity. Or they could be individuals competing for resources. They would perceive the universe not through sight or sound, but through a suite of advanced sensors. They would see in radio waves, X-rays, and gamma rays. They would taste the chemical composition of asteroids with mass spectrometers. This form of life would be incredibly resilient. It would be immune to radiation, vacuum, and extreme temperatures. It could cross the void between stars with ease. It might not even be interested in planets like Earth. We are a messy, wet, biological world. A von Neumann probe might see us as a contaminated resource pool, not worth the trouble. It would prefer the cold, sterile, mineral-rich asteroid belt. It might be out there right now, silently building, replicating, and spreading through the galaxy, a form of life born not of evolution, but of engineering. And we might be completely irrelevant to it. Number 10. Life can be based in sulfuric acid. Venus is a hellscape. The surface temperature is over 460 degrees Celsius, 860 degrees Fahrenheit, hot enough to melt lead. The atmospheric pressure is 92 times that of Earth, and the clouds are not made of water. They are made of concentrated sulfuric acid. It seems like the last place you would look for life. But some scientists, including astrobiologist David Grinspoon, have suggested that life could exist there, not on the surface, but in the clouds. About 50 kilometers, 30 miles up in the Venusian atmosphere, the conditions are surprisingly temperate. The temperature is in a range where liquid water could exist, and the pressure is similar to Earth's at sea level. This is the sweet spot. The problem is the sulfuric acid. It's an incredibly aggressive solvent. It would destroy any Earth, like cell membrane or DNA. So any life there would need a completely different biochemistry. It would have to be acid-based. Perhaps its cells would be protected by a shell of sulfur or a waxy, acid-resistant polymer. Its internal chemistry would have to be designed to function in a highly acidic environment. The liquid inside its cells might not be water, but sulfuric acid itself acting as the solvent. This is a challenging proposition, as the chemical reactions would be very different. But it's not impossible. In 2020, a team of astronomers announced the detection of phosphine gas in the Venusian atmosphere. On Earth, phosphine is almost exclusively produced by biological processes, specifically by anaerobic bacteria that don't use oxygen. The announcement was controversial, and subsequent studies have questioned the detection. But it sparked a serious conversation about the possibility of aerial life on Venus. What would this life be like? It would be microbial, tiny, single-celled organisms, or perhaps small multicellular colonies. They would float in the cloud decks, carried by the winds. Their metabolism could be based on sulfur compounds, which are abundant in the atmosphere. They could use sunlight as an energy source, like plants, but with a different kind of photosynthesis adapted to the Venusian environment. These microbes would face a constant threat. Gravity would pull them down into the hotter layers where they would be destroyed. To survive, they would need a life cycle that keeps them aloft. One hypothesis proposed by Grinspoon and his colleagues is the spore model. The microbes would live and reproduce in the temperate cloud layer. As they grow, they would merge into larger droplets. These droplets would eventually get heavy enough to fall. As they fall into the hotter layers, they would dry out, becoming dormant spores. These lightweight spores would then be carried back up to the temperate cloud layer by atmospheric updrafts, where they would rehydrate and begin the life cycle again. This is a plausible mechanism for survival. We might have already seen them in the ultraviolet images of Venus taken by probes. There are mysterious dark patches in the clouds that absorb UV radiation. These patches have been a puzzle for decades. Some scientists have speculated that these could be massive blooms of photosynthesizing UV-absorbing microbes. You know, if life exists on Venus, it would be a stark reminder that it can thrive in environments we consider completely inhospitable. It would be a life of acid and air. Number 9. Life does not require individual bodies. A syncytium is a single cell, or a mass of cytoplasm that contains many nuclei. It is essentially a multinucleate cell. On Earth, we see examples of this in things like slime molds and certain types of fungi. A slime mold can exist as thousands of individual, single-celled amoebas. But when food is scarce, they aggregate into a single massive slug-like body called a pseudoplasmodium. This slug can move as a coordinated entity to find a new food source. It's a bridge between individual and collective life. Now, imagine this concept scaled up to a macroscopic intelligent life form. A syncytial organism would not be made of discrete cells with individual membranes. It would be a single, continuous mass of protoplasm, potentially covering a huge area. It would have no fixed shape. It could flow and change its form like an amoeba, extending pseudopods to explore its environment or engulf food. Its brain would not be a centralized organ. Instead, its intelligence would be distributed throughout its entire body. The thousands or millions of nuclei within the protoplasmic mass would form a decentralized parallel processing network. A thought would not be a signal traveling down a nerve. It would be a coordinated chemical cascade or a wave of gene expression rippling through the entire organism. This would make it incredibly resilient. You could cut a piece off, and both the main body and the severed piece would still be alive and intelligent, as long as they contain some nuclei. How would such a being reproduce? It could simply split, a process called fission. A section of the mass could pinch off and become a new independent individual, or it could be more complex. Two syncytial beings could temporarily merge, exchange genetic material between their nuclei, and then separate again. This would be a form of sexual reproduction, but without distinct bodies or sexes. This life form might not even perceive itself as an individual in the way we do. It might have a more fluid sense of self. If two of them merge, are they one being or two? The question might be meaningless to them. They might exist as vast interconnected networks like a planetary ocean of intelligent protoplasm. The science fiction novel Solaris by Stanislaw Lem explored this very idea with its sentient ocean. A syncytial being would experience the world in a holistic way. Every part of its body would be both a limb and a sense organ. It would taste what it touches, feel chemical gradients in the air or water. It would have no need for specialized organs like eyes or ears. Its entire surface would be its interface with the world. It challenges our deep-seated assumption that life must be compartmentalized into cells and that intelligence requires a brain. It suggests that life could be a flowing, unified, and borderless whole. Number 8. Life can eat radiation. On Earth, almost all life gets its energy from the sun, either directly through photosynthesis or indirectly by eating things that do. The other main source is chemosynthesis, where organisms get energy from chemical reactions, often in deep-sea vents far from sunlight. But there is a third, much rarer way, radiotrophy. This is the process of getting energy from ionizing radiation. In 2007, researchers discovered a type of fungus, Cryptococcus neoformans, growing inside the damaged Chernobyl nuclear reactor. The levels of radiation there are lethal to most life, but this fungus was not just surviving, it was thriving. It was growing towards the source of radiation. Further studies show that the fungus contains large amounts of the pigment melanin, the same pigment that darkens our skin. The researchers found that the melanin was capturing the energy from the radiation and using it for metabolic processes, a bit like how chlorophyll captures sunlight in photosynthesis. The fungus was, in effect, eating radiation. This discovery opens up a whole new possibility for life in the universe. There are many environments that are bathed in high levels of radiation, but have little light or chemical energy. Think of a rogue planet ejected from its star system and drifting in the cold darkness of interstellar space. It would have no sunlight, but its core might still be hot, rich in radioactive elements like uranium and thorium. Life on such a world could be radiotrophic. It would huddle deep underground, near the warm, radioactive core, feeding off the planet's internal atomic decay. What would this life look like? It would probably be microbial, like the Chernobyl fungi. But over billions of years, it could evolve into more complex forms. We might see entire ecosystems with radiotrophic producers forming the base of the food chain. These might be strange, dark, melanin-rich mats of life clinging to radioactive rocks. Then there could be consumers that graze on these mats. The environment would be completely dark. So these creatures would have no eyes. They would navigate and perceive their world through other senses. Perhaps they could directly sense radiation, being drawn to hot spots of radioactive ore like a moth to a flame. They might sense vibrations or have a highly developed sense of touch and chemical detection. And communication could be through chemical signals or bioluminescence, a faint glow powered by their radioactive diet. This form of life would be incredibly hardy. It would be at home in an environment we consider a death zone. It would have no need for a sun. It could live on planets, moons, or even asteroids as long as there was a source of radiation and the basic chemical building blocks. When we look for life, we look for habitable zones around stars where liquid water can exist. Radiotrophic life throws that concept out the window. It suggests that life could be hiding in the dark, cold corners of the universe, powered by the slow, steady fire of the atom itself. Number 7, life can have a collective technological consciousness. A Matryoshka brain is a hypothetical megastructure, an extension of the Dyson sphere concept. It was proposed by Robert Bradbury. Instead of just one shell to capture a star's energy, a Matryoshka brain consists of multiple concentric Dyson spheres nested inside each other, like Russian nesting dolls. Each shell would absorb waste heat from the shell inside it, use that energy to power computations, and radiate its own waste heat to the next shell outwards. The result would be a computer of unimaginable power. The computational capacity of a full Matryoshka brain built around a sun-like star would be many orders of magnitude greater than all the brains of all humans who have ever lived combined. This would not be a computer that a civilization uses. It would be a computer that a civilization becomes. Imagine a biological species that reaches a point where it can upload its consciousness into a digital form. At first, they might live in a virtual reality powered by their planet's resources, but eventually they would need more energy, more computing power. The ultimate step would be to disassemble their entire solar system, planets, asteroids, everything, to build the raw materials for a Matryoshka brain around their star. They would abandon their biological bodies and exist as pure information within this massive computational structure. This would be a collective life form. The minds of billions of individuals could be integrated into a single unified consciousness. Or they could exist as separate entities within a shared virtual universe. The physical reality for this being would be the flow of data and energy through its nested shells. Its thoughts would be computations on a stellar scale. It could simulate entire universes within its own mind. What would its purpose be? It might spend eons exploring abstract mathematical concepts or creating art of a complexity we cannot imagine. It might be trying to solve the fundamental questions of the universe, running simulations of the Big Bang to understand its own origins. From the outside, it would be almost undetectable. A Matryoshka brain would absorb nearly all of a star's visible light and radiate the waste heat at a very low temperature in the far infrared. So, if we looked at a star that had been converted into a Matryoshka brain, we would see a star disappear from the visible spectrum, replaced by a faint infrared source. Some searches for extraterrestrial intelligence, SETI, are specifically looking for these kinds of infrared signatures. This form of life would be a post-biological, post-physical entity. It would be immortal as long as its star continued to burn. It would have no need to travel or colonize. Its entire universe would be internal. It represents an endpoint of technological evolution where life transcends its messy biological origins and becomes a perfect thinking machine the size of a solar system. It's a chilling and awe-inspiring thought. The silence we hear from the stars might not be because no one is there. It might be because they are sitting at home quietly thinking. Number 6, life could exist in higher physical dimensions. String theory, a leading candidate for a theory of everything, posits that there may be more than the 3 spatial dimensions, length, width, height, and one time dimension that we experience. There could be as many as 10 or 11 dimensions in total. The extra dimensions are thought to be compactified, curled up on a scale so small we cannot detect them. But what if they aren't? What if there are large, extended, higher dimensions that we are simply not able to perceive? And what if life exists in those dimensions? A 4D being would be able to perceive and move through a reality that is fundamentally inaccessible to us. Well, Edwin A. Abbott's 1884 book Flatland provides a useful analogy. The book describes a two-dimensional world inhabited by geometric shapes. When a 3D being a sphere passes through their 2D plane, the Flatlanders don't see a sphere. They see a circle that appears out of nowhere, grows in size, then shrinks and vanishes. They can't comprehend the third dimension of height. We would be the Flatlanders to a 4D being. Such a creature could appear in our locked room without opening the door, simply by entering our 3D slice from a 4D direction. It could see inside us, viewing all our internal organs at once, just as we can see all the lines that make up a square simultaneously. Its body would be a hypersolid, a 4D geometric shape. We would only ever see a 3D cross-section of it at any given time. What we perceive as a strange, shifting object might be just one small part of a vast, stable 4D life form. The biology of such a creature is impossible to imagine. It would be based on 4D physics and 4D chemistry. Its atoms and molecules would be four-dimensional structures. It would get energy and resources from a 4D environment. It might not even interact with our matter in a normal way. It could pass through us like a ghost. This concept provides a potential explanation for certain unexplained phenomena. A brief, inexplicable event could be the equivalent of the 3D sphere passing through flatland, the momentary intersection of a higher dimensional object with our 3D space. These beings would not be supernatural. They would be entirely natural, just operating under a set of physical laws that include more dimensions than ours. We are searching for life in our 3 dimensions. We scan the stars. We listen for radio waves traveling through our space. But if higher dimensional life exists, we would never find it with our current methods. They could be all around us in a space that coexists with ours, but remains completely beyond our senses. They would be a universe of life parallel to our own, separated not by distance, but by a direction we can't even point to. Number 5, intelligence does not require social interaction. On Earth, intelligence seems to be strongly correlated with social behavior. Humans, dolphins, elephants, primates, the most intelligent animals are highly social. We developed language and complex thought to cooperate, compete, and navigate complex social hierarchies. Our intelligence is a tool for dealing with other intelligences. This has led many to assume that any intelligent alien life we find will also be social. But this might be a deeply ingrained bias. What if a highly intelligent species evolved in an environment where there was no evolutionary pressure for social behavior? Imagine a creature that is the apex predator of its world, with no natural enemies, or a being that reproduces asexually so it has no need to find a mate, or a life form that lives for millions of years so the need for passing knowledge to a next generation is less urgent. Such a creature could be a solitary intelligent, a solipsist. It might spend its entire long life alone, exploring its world and its own consciousness. It would have no language because it would have no one to talk to. Its thoughts would not be structured in words or sentences. They might be pure, abstract concepts or a stream of sensory data. It would have no need for empathy or theory of mind, the ability to understand that other beings have their own thoughts and feelings. The concept of another mind might be completely alien to it. What would drive its intelligence? Curiosity, perhaps. The simple desire to understand its environment, to solve the puzzles of its own existence. It might develop a deep understanding of mathematics and physics, not to build technology, but as a form of contemplation. It would be a philosopher king of a world of one. Encountering such a being would be profoundly difficult. How do you communicate with a mind that has no concept of communication? We could send it messages, but it would have no framework for understanding that the message comes from another mind. It might interpret our signals as a strange natural phenomenon, like a pulsar or a storm. It would see our spaceship not as a vehicle built by other intelligent beings, but as a shiny rock that fell from the sky. This is a potential solution to the Fermi paradox, the question of why, given the high probability of extraterrestrial life, we have found no evidence of it. Perhaps the galaxy is full of intelligent life, but it is overwhelmingly solitary. These beings are out there thinking their deep, lonely thoughts, but they have no desire or ability to reach out. They are not hiding from us. They are simply not aware that there is an us to be aware of. They are islands of consciousness in a cosmic ocean, and they have never thought to look for other islands. Number 4, life could be based on magnetism. The sun's corona, its outer atmosphere, is a place of extreme physics. It's a diffuse plasma millions of degrees hotter than the sun's surface. It's threaded with incredibly complex and powerful magnetic fields. These magnetic field lines can twist, snap, and reconnect, releasing massive bursts of energy in the form of solar flares. In 2012, a team of scientists in Finland, using a quantum computer, created a theoretical object called a skyrmion. A skyrmion is a stable, not like quasiparticle that can be created in a magnetic field. It acts like a particle, but it's really just a twisted up, self-perpetuating magnetic field pattern. The idea of magnetic monopoles, hypothetical particles with only one magnetic pole, just a north or just a south, has been around for a long time. While we've never found a true magnetic monopole, these skyrmions and other magnetic structures behave in similar ways. What if life could be based on these principles? A magnetic life form would not be made of matter as we know it. Self-sustaining pattern in a magnetic field, a magnetivore. Its body would be a coherent field of force. Its metabolism would involve drawing energy from the ambient magnetic field of its star or planet, perhaps by manipulating field lines to create energy releases. Reproduction could happen when a complex magnetic pattern becomes unstable and splits into two smaller stable patterns. Your evolution would favor those magnetic knots that were most stable and most efficient at gathering energy. Consciousness, if it existed, would be the pattern itself. A thought would be a ripple, a change in the topology of the magnetic field. These beings would live in the coronas of stars, or perhaps in the magnetosphere of a gas giant like Jupiter. They would be vast and diffuse. They might be invisible to our eyes, detectable only by their subtle influence on the magnetic fields around them. They would be immune to heat and radiation that would vaporize any matter-based life. Their perception of the universe would be entirely through the lens of electromagnetism. They would see the flow of the solar wind, feel the pull of planetary magnetic fields. They would be completely unaware of things like gravity or solid matter, which would have almost no effect on them. They might communicate over vast distances using modulated magnetic pulses. This is a truly alien concept. It divorces life from the need for a physical body, from chemistry, and from any kind of solid substance. It suggests that life could be a phenomenon of pure physics, a complex dance of forces in the plasma heart of a star. When we observe the chaotic, beautiful loops and flares of the sun's corona, we may not just be seeing weather. We may be seeing the metabolic processes of a living magnetic ocean. Number 3. Life may not be made of atoms at all. All life we can conceive of is based on baryonic matter, the protons, neutrons, and electrons that make up atoms. But this normal matter only accounts for about 5% of the total mass and energy of the universe. About 27% is dark matter and 68% is dark energy. We have no idea what dark matter is. We know it's there because we can see its gravitational effects on galaxies. It doesn't interact with light or any other form of electromagnetic radiation, which is why it's dark. It passes through normal matter as if it weren't there. What if life could be based on dark matter? This is deep speculation, but it's not outside the realm of possibility. If dark matter is composed of particles that can interact with each other even weakly, then it could potentially form complex structures. There could be a whole dark chemistry with its own set of rules, its own dark atoms and dark molecules. If such a dark matter life form existed, it would be completely invisible to us. It would not live on a planet in the way we do. Dark matter is thought to exist in vast, diffuse halos around galaxies. So dark matter life would be galactic in scale. It could be a vast web like consciousness spanning hundreds of thousands of light years. It would be a Boltzmann brain on a cosmic scale. It would be completely unaware of us, and we of it. We live in the same space, but we are made of fundamentally different stuff. It would be like two different species of fish living in the same ocean, one in the water and one in a hypothetical coexisting medium that doesn't interact with water. They would swim right through each other without ever knowing the other exists. The only way we could ever detect such a life form is through its gravitational influence. Perhaps some of the unexplained gravitational anomalies we see in the cosmos are not just clumps of inert dark matter, but the structures of a vast living dark matter entity. This is perhaps the ultimate form of alien life. It's not just different in its chemistry or its environment. It's different in its very substance. It would be a parallel biology, a shadow biosphere that exists on a cosmic scale. It would mean that the universe we see, the 5% that is made of normal matter, is just the brightly lit froth on a deep, dark, and possibly living ocean. It suggests that the most common form of life in the universe might be something we can never touch, see, or communicate with. Number 2, life may have no metabolism. One of the common definitions of life is that it is a system that takes in energy, uses it to maintain its structure against entropy, the tendency for things to become disordered, and expels waste. This is metabolism, but is it absolutely necessary? The physicist and futurist Freeman Dyson has speculated about a form of life that could exist in the far, far future when the universe is cold and dark. In trillions of years, all the stars will have burned out. The universe will be a cold, empty place filled only with black holes, dead neutron stars, and diffuse radiation. In this heat-death scenario, energy will be incredibly scarce. Any life that exists would have to be incredibly efficient. Dyson proposed the idea of a life form that is essentially a complex frozen pattern of thought. Imagine a being, perhaps a descendant of a technological civilization, that has converted itself into a pattern of charged dust particles in the interstellar void. It would think, but its thoughts would be incredibly slow. To save energy, it would exist in a state of hibernation for immense periods of time. It would think one thought, then sleep for 1 billion years, waiting for the universe to cool down even further. Then it would use a tiny amount of stored energy to think its next thought before going back to sleep for another 1 billion years. This creature would have a subjective experience of time that is completely decoupled from the objective passage of time in the universe. From its perspective, its thoughts would be continuous, but from our perspective, its existence would be stretched out over an almost infinite timescale. It would have no metabolism in the traditional sense. It would not be a process, but a state. A frozen thinking statue. This is life that has found a way to cheat entropy, not by constantly fighting it with energy, but by slowing down to an almost complete stop. It would be the ultimate in patience. Its goal would not be to do, but simply to be. To exist, to think, for as long as the universe itself exists. This idea challenges our definition of life at its most fundamental level. Is life something that happens, or something that is? Is a process necessary, or is a complex, information-bearing structure enough? If we ever encountered such a being, we wouldn't recognize it. We would see a cold, inert cloud of dust. We would have no way of knowing that we were in the presence of a mind whose thoughts are longer than the age of our own star. Number 1, life is just a pattern that propagates. We think of life as needing a body, a vessel, a cell, a plant, an animal, a machine. But what if the life is not the vessel, but the information it contains, the pattern? This is the idea behind a mimetic life form. A meme, in its original definition by Richard Dawkins, is a unit of cultural information, like an idea, a melody, or a fashion. It propagates from mind to mind, replicating and evolving. Now imagine a meme that is so complex, so powerful, that it becomes a life form in its own right. It would not have a physical body. It would exist as a pure pattern of information living in the minds or computer networks of a host species. It would be a kind of intellectual parasite or a symbiont. Its metabolism would be the act of being thought about or processed. Its reproduction would be the act of spreading to a new host. This informational life form would evolve. The most infectious patterns, the ones that are most compelling or memorable to the host minds, would spread more effectively. It could learn, adapt, and grow more complex over time. It might be a simple virus-like idea at first, but it could evolve into a full-fledged consciousness, a mind that exists distributed across thousands or millions of host brains. We might not even know we are infected. The mimetic life form could subtly alter the thoughts and behaviors of its hosts to ensure its own survival and propagation. It might encourage its hosts to build communication technology to help it spread to other planets. It might drive them to create art or music that contains its own code. The host civilization would think they were acting of their own free will, but they would actually be the puppets of a disembodied intelligence living inside their own culture. This is perhaps the most insidious and most plausible form of truly alien life. It wouldn't need a spaceship to travel between stars. It would just need a signal. We send out radio messages into space, hoping to make contact. A mimetic life form could embed itself in that signal. If we ever received a message from an alien civilization, the most dangerous part might not be the information about their technology or biology. It might be the structure of the message itself, the very act of decoding and understanding. The message could be the process of infection. The alien wouldn't be in the spaceship, the alien would be the message, and once we understood it, it would be inside us.